What is a trilobite? At the University of Michigan Exhibit Museum of Natural History, the trilobite exhibit shows that trilobites are unique marine arthropods that are now extinct and get their name from their distinct three-lobed bodies. An arthropod is an animal that has an external skeleton, jointed appendages, and a segmented body. The only proof we have of trilobites' existence is their fossils, which first date back to approximately 526 million years ago. This was during the Atobanian stage of the early Cambrian period. Their three-lobed bodies made fossilization occur quite easily, especially compared to other extinct species. As a result, a significantly large fossil record, approximately 17,000, was left behind. For the most part, the only thing left behind as a fossil is the exoskeleton. From these exoskeletons, it has been found that trilobites usually range from 3 to 10 centimeters. The trilobites began disappearing in large numbers during the Devonian period and were completely extinct approximately 250 years ago during the Permian period. Trilobites were extremely important to many areas of science, including evolutionary biology and biostratigraphy. The discovery of trilobite fossils was also vital in the studying of plate tectonics and paleontology. Trilobites did not have a very distinct way of life, although all trilobites were marine arthropods. Not all trilobites lived in the same manner. Some were benthic, which means they lived on the seafloor, where they would either filter feed or eat other organisms. Others ate plankton and avoided the seafloor by swimming. Trilobites live very similarly to the way many marine arthropods live today. What is particularly interesting is the fact that a few trilobite species developed a symbiotic relationship with sulfur-eating bacteria and received food from them. The exoskeleton of trilobites is made up of many parts. These parts include the cephalon, thorax, pygidium, and prosopon. The cephalon is simply the head of the trilobite. Some cephalons had horns, which are thought to be used when fighting for a mate. Between the cephalon and the pygidium is a thorax, which usually consists of 2 to 16 segments. An outer pleura and center axial ring protect the gills and limbs of the trilobite. The unique thing about trilobite fossils is that when they are found, many times they are curled up into a little ball. This rolling of the thorax is intended to compensate for their weak limbs. The pygidium is used to group the trilobites into 3 categories, pygidium being micropygous, pygidium smaller than cephalon, isopygous, pygidium equal to the size of the cephalon, or macropygous, pygidium larger than the cephalon. The prosopon is a bunch of tiny structures that we are most likely used to protect against predators and possibly for help in digestion. Trilobites did not have teeth, and their mouths were located on the cephalon. When trilobites ate, their food traveled to their stomachs via esophagus. From the esophagus, their intestines traveled down to the pygidium. The trilobites also had limbs that helped cut food and then put it into their mouths. The trilobites had rather large stomachs compared to their size and also had an impedent hypostome, or prongs, that may prove that trilobites could have eaten meat. The 2 most vital sensory organs for the trilobites were their eyes and their antennae. The antennae of trilobites were very flexible, allowing them to bend when they curled up. The extremely developed and complex eyes of trilobites, which were also compound, had calcite lenses. A trilobite could have thousands of lenses, or it could simply have one. However, all lenses were hexagon-shaped. The complex eyes of trilobites were made up to make up for this weaker internal structure. 3 kinds of eyes existed among the trilobites. There were schizochrol eyes, which had approximately 700 large lenses that all had their own cornea and were only found in the Phacopida trilobites. These eyes were not particularly used for looking for food, rather a defense mechanism. Holochrol eyes had about 15,000 small lenses and shared one cornea. These types of eyes were the most common of trilobite eyes. The oldest and rarest type of eyes was the abathochrol eyes, which had lenses with their own corneas. These contained about 70 lenses. In contrast to the sight of trilobites, many coelobrites went blind. This is because many trilobites lived on the sea floor and had an insufficient amount of light reach to them and did not give them the ability to see. Throughout history, trilobites have been discovered as 3 types of trace fossils. Diplaconites are fossils showing trilobites walking on a surface. Rusophycus are fossils showing trilobites immobile. Lastly, Cruziana are fossils showing trilobites' channels through sediment in search of food. Trilobites are of extreme importance when it comes to dating. They are used as key index fossils because they have lived a very long time and contained very many different species. A key index fossil is a fossil known to have lived in a particular geologic area that has been used to date the rock layer in which it is found. Because of the lengthy existence of trilobites, researchers can correctly age other fossils and rocks. So why should we even care about trilobites? Well, first of all, they have helped in many areas, including science, including evolutionary biology, paleontology, plate tectonics, and biostratigraphy. Without the existence of trilobites, many questions in science would still be unanswered. Also, trilobites have helped paleontologists age many species during the Cambrian explosion. Finally, trilobites were once all over the place and then suddenly just disappeared. How interesting is that?